You snap a photo on your phone. It's perfect. The lighting, the smile, everything. You tap a little cloud icon and poof. It's safe. Gone from your device but secure somewhere else. Later, you're on your couch, you open Netflix and instantly, a library of thousands of movies is at your fingertips. You ask your smart speaker for the weather, and a voice tells you it's 72 and sunny. You send a work email from a coffee shop. You collaborate on a document with a colleague 1,000 miles away. You play a video game against someone on the other side of the planet. What is the invisible, instantaneous magic that connects all of this? You use it hundreds of times a day, every single day, and you probably don't even think about it. It's a technology that powers nearly every facet of modern American life, from the most powerful algorithms on Wall Street to the family photos on your grandma's iPad. And yet, for most people, it's a complete and total mystery. We're talking about the cloud. We hear the term constantly. Upload it to the cloud. It's all backed up in the cloud. Our company is migrating to the cloud. It's become this cultural catch-all for what exactly? It sounds like some magical, fluffy, ethereal place up in the sky where our data goes to live. But what is it, really? Where is this cloud? Is it one giant supercomputer floating over Silicon Valley? Is it a satellite? And more importantly, why on earth should you care? Here's the deal. Understanding the cloud isn't just for tech geeks and hoodies anymore. It is essential knowledge for anyone who uses a smartphone, watches television, runs a business, applies for a job, or simply wants to grasp the fundamental forces shaping our world. In this video, I am going to pull back the curtain on the single most important and most misunderstood technology of the 21st century. And I'm making you a promise. I am going to demystify the cloud completely. No confusing jargon, no boring technical diagrams that look like a bowl of spaghetti. I'm going to explain it so simply, so clearly, that by the end of this you'll be able to explain it to your friends, your parents, or your boss and sound like a genius. We're going to break down what it is, why it even exists, and how it quietly grew from a niche academic idea into a multi-trillion-dollar industry that giants like Amazon, Microsoft, and Google are betting their entire futures on. And when we're done, you won't just know what the cloud is. You will see with perfect clarity how it impacts your wallet, your career, your personal security, and your daily habits in ways you never ever imagined. You'll finally understand the incredible power you are tapping into every single time you hit save. So, to start, let's forget about computers entirely for a minute. Let's talk about electricity. Go back 150 years. If you owned a factory making, say, furniture, and you needed power for your saws and lathes, you had one option. You had to build your own power plant. Right there on site. You had to buy a massive, expensive generator. You had to hire specialized engineers to operate it and maintain it. You had to buy coal or oil to fuel it. You had to deal with it when it broke down. It was a colossal, expensive, and complicated headache. Your main business was making furniture, but you were forced to also be in the power generation business just to operate. Then, something happened that changed the world. The power grid was invented. Suddenly, you didn't need your own power plant anymore. You could just run a wire from your factory to a pole on the street and plug in. You could get all the power you needed from a massive centralized utility company. And the best part? You only paid for the exact amount of electricity you used. It was infinitely cheaper, far more reliable, and it freed you up to focus on what you were actually good at, making furniture. The cloud is the exact same idea, but for computing power instead of electricity. That's it. That's the big secret. The cloud is not a mystical, magical thing. It is, quite simply, someone else's computer. Now, it's not just one computer in a basement somewhere. It's a massive global network of millions of computers. I want you to picture gigantic, windowless buildings, some the size of several football fields, scattered all across the country and the world. In rural Oregon, in Northern Virginia, in Ohio, these buildings are called data centers. Inside, it's like a scene from a sci-fi movie. Row after row after row of tall metal racks, each packed from floor to ceiling with powerful computers called servers. Thousands of them, hundreds of thousands of them, all humming with activity, blinking with little green lights, and cooled by roaring industrial-scale air conditioning systems. The whole operation is connected directly to the backbone of the internet with incredibly fast, high-bandwidth fiber optic cables. Companies like Amazon with their Amazon Web Services or AWS, Microsoft with their Azure platform, and Google with Google Cloud have spent hundreds of billions of dollars building these colossal data centers all over the planet. And just like the old power utility company, they now rent out access to all of those computers. So, instead of a business, say Netflix, buying thousands of its own expensive servers, finding a building to store them, hiring a huge IT team to manage them, and worrying about them breaking down or running out of storage space, they can just plug into the cloud over the internet and rent the exact amount of computing power they need from Amazon. Think of it like this. It's the difference between buying a house and renting an apartment. Buying a house is a huge upfront investment. You have the mortgage, the property taxes, the insurance. When the roof leaks or the water heater breaks, that's your problem. It's all on you. Renting an apartment is totally different. You just pay a monthly fee. The landlord, the building owner, they handle all the maintenance, the security, the plumbing, the infrastructure. You just get to live there and use the space as you need it. The cloud is exactly that. It's renting computing power instead of owning it. So why did this become the dominant way of doing things? Why did basically every company, from the smallest startup to the Central Intelligence Agency, decide to stop buying their own computers and start renting them? It boils down to 3 revolutionary advantages: cost, scale, and speed. First, cost. It is just way cheaper. It's a classic economy of scale. It is far more affordable for Amazon to buy 10 million computer servers than it is for a small business to buy 10. Amazon gets massive bulk discounts on hardware. They design their own hyper-efficient computer chips. They build their own power substations next to their data centers to get cheaper electricity. They can then pass all those savings on to their customers. For a startup founder with a new app idea, this is a game changer. Instead of needing to raise $500,000 just to buy computer hardware before they've even made a single sale, they can now pull out a credit card, pay a few dollars a month to Amazon, and get started instantly. Completely leveled the playing field. Second, and this is the part that is truly mind-blowing, is scale. Let's imagine you run an online store that sells tickets for a big concert. For most of the year, you get a few thousand visitors a day, and your small, rented slice of the cloud handles it just fine. But then, tickets for the biggest artist in the world go on sale. And in 1 second, 10 million people rush to your website. If you were using your own servers in your office, they would instantly melt. The website would crash. No one gets tickets, everyone is angry, and you've lost millions in sales. It would be a catastrophe. But with the cloud, something incredible happens. The cloud provider, like Microsoft Azure, sees this unimaginable spike in traffic coming. And automatically, in a fraction of a second, it assigns thousands of additional servers and a massive amount of computing power just to your website to handle the load. Your website's capacity expands instantly. It's like your 2-lane country road suddenly transforming into a 20-lane superhighway. The 10 million fans buy their tickets, the website stays online, and everything works. Then, an hour later, when the rush is over, the cloud automatically scales you back down to your normal small size. And you only paid for that massive superhighway of power for the 1 hour you actually used it. This ability to instantly and automatically grow or shrink is called elasticity. And it's a superpower that was practically impossible before the cloud. And finally, there's speed. Not just the processing speed of the computers, but the speed of innovation. In the old days, if a developer inside a big company had a brilliant new idea, the process was a nightmare. They'd have to write a proposal, get budget approval, have the IT department order a new server, wait 6 weeks for it to be delivered, wait for someone to install it in the server room, configure the software. It could take months just to get started. By the time they were ready, the opportunity might have passed. Today, with the cloud, that same developer can have an idea in the morning, pull out a company credit card, and with a few clicks of a mouse, have access to a virtual supercomputer in minutes. This has unleashed a tidal wave of innovation. Companies we use every day, Airbnb, Uber, Slack, Pinterest, Instagram, they were all born in the cloud. They could never have gotten off the ground so quickly or grown so explosively fast without it. So let's bring it all back home. The cloud isn't a cloud. It's not a single thing in the sky. It's a service. It's a new model for how we access computing resources, things like data storage, powerful servers, networking, software, over the internet from those gigantic, ultra-efficient data centers owned by someone else. It is the electricity grid for our digital world. And it has fundamentally changed how we build companies, how we consume entertainment, and how we store our most precious memories. But this is just the first layer. We've defined what it is. But how does it actually work on your phone? When you save a photo to iCloud or Google Photos, what is physically happening inside those data centers to make that possible? And what are the different types of cloud services that companies are paying billions and billions of dollars for? You might have heard a whole alphabet soup of confusing acronyms. IaaS, PaaS, SaaS. They sound incredibly complicated, but I promise you, they are actually very simple once you understand the basic concept we just covered. And that is exactly where we're going next. So let's tackle those three big ones head on. Infrastructure as a service, platform as a service, and software as a service. IaaS, PaaS, and SaaS. I know it sounds like a bad eye chart, but to make this incredibly easy to understand, we're not going to talk about computers at all. We're going to talk about pizza. Everybody understands pizza. Whether you make it from scratch, get it from a take-and-bake place, or have it delivered piping hot to your door, you get the concept. And those three ways of getting pizza perfectly mirror the three main types of cloud services. Let's start at the most fundamental level. Making pizza completely from scratch at home. You have to buy the flour, the yeast, the tomatoes, the cheese. You have to make the dough, let it rise, make the sauce. You need to own an oven, have baking sheets, a pizza cutter. You're responsible for everything. The ingredients, the equipment, the labor, the cleanup. This is the traditional non-cloud way of doing things in the tech world. It's like a company buying its own physical servers, installing the operating systems, managing the network, and running its own data center. They own and manage everything. It gives you total control, but it's also a ton of work and a massive expense. Now let's get into the cloud. Our first stop is IaaS, infrastructure as a service. Imagine you want to make your own signature pizza, but you don't want to buy a whole professional kitchen. You don't want to deal with buying a $10,000 brick oven, a giant industrial mixer, or a walk-in refrigerator. So instead, you rent a space in a commercial kitchen. The kitchen comes with the oven, the fridge, the counters, the electricity, the water. All the basic infrastructure is provided for you. You just show up with your own special ingredients, your secret sauce recipe, your artisanal cheese, your unique toppings. You get to use their top-of-the-line equipment to make your pizza exactly how you want it, but you're not responsible for maintaining that oven or paying the electricity bill for the building. That is infrastructure as a service. In the tech world, instead of renting a kitchen, you're renting computing infrastructure. You're renting virtual servers, storage space, and networking from a cloud provider like Amazon Web Services, Microsoft Azure, or Google Cloud. You're not buying a physical server and putting it in a closet. You're just renting the raw computing power. You still have to bring your own ingredients. You have to install your own operating system, your own software, and manage your own applications. But you don't have to worry about the physical machine, the power, the cooling, or the network connection. The cloud provider handles all of that underlying hardware. So IaaS gives you the raw building blocks. It's for people who want a lot of control over their software environment, but don't want the headache of managing physical hardware. Think of it as renting the kitchen. Okay, so what's the next level of convenience? That brings us to PaaS, platform as a service. Let's go back to our pizza night. This time, you don't want to bother with making the dough or the sauce. It's a hassle. So you go to one of those take-and-bake pizza places. You walk in, and they provide everything you need to assemble the pizza. They have the pre-made dough already rolled out for you. They have the sauce, the cheese, and all the toppings laid out in a buffet-style line. All you have to do is the fun part. You tell them what you want on it. I'll take the sourdough crust, extra sauce, mozzarella, pepperoni, and mushrooms. You assemble your perfect pizza, they wrap it up, and you take it home to bake in your own oven. You didn't have to worry about the infrastructure, the kitchen, and you didn't have to worry about the basic platform, the dough and the sauce. You just focused on creating your unique pizza. That is platform as a service. In the tech world, PaaS is a service that provides a platform allowing developers to build, run, and manage applications without the complexity of building and maintaining the infrastructure typically associated with it. The cloud provider gives you not just the servers and storage, the kitchen, but also the operating system, the databases, and the programming language environments, the dough, sauce, and cheese. The developer just brings their unique code, their application, and deploys it on the platform. They don't have to worry about operating system updates or database maintenance. All of that is handled for them. It lets them focus purely on writing the code for their great new app. Services like Heroku or Google App Engine are classic examples of PaaS. So PaaS is for developers who want to build and deploy applications quickly without managing the underlying systems. Think of it as the take-and-bake pizza place. Now for the final and most common type of cloud service. SaaS, software as a service. You've had a long day. You don't want to rent a kitchen. You don't even want to go to a store to assemble a pizza. You just want to eat pizza. So you pick up your phone, open an app, tap a few buttons, and 30 minutes later, a delicious hot pizza arrives at your door. You don't know who made it. You don't know what kind of oven they used. You don't care about their dough recipe or where they got their cheese. You just paid for a finished, ready-to-eat product. You are simply a consumer of the pizza service. That is software as a service. This is the form of cloud computing that nearly everyone on the planet uses every single day, often without even thinking about it. SaaS is a fully baked, ready-to-use software application that you access over the internet, usually through a web browser or a mobile app. When you check your email with Gmail, you're using SaaS. When you watch a movie on Netflix, you're using SaaS. When you listen to music on Spotify, collaborate on a document in Google Docs, or manage a project in Trello, that is all software as a service. You don't download any software to your computer's hard drive. You don't manage any updates. You don't worry about the servers, the code, or the database. You just log in and use it. The company that provides the service handles everything behind the scenes. All the complexity is hidden from you. You just get the benefit of the final product. It's the most hands-off approach, where you simply consume a service that is delivered to you over the internet. It's ordering a pizza for delivery. So let's recap this with our pizza analogy one last time so it really sticks. Traditional, on-your-own computing is making pizza from scratch at home. You manage everything. IaaS, infrastructure as a service, is renting a commercial kitchen. The provider manages the building and the ovens. You manage the ingredients and the baking. PaaS, platform as a service, is going to a take-and-bake pizza place. The provider manages the kitchen and the basic ingredients like dough and sauce. You just manage assembling your pizza and what toppings to put on. And SaaS, software as a service, is ordering a pizza for delivery. The provider manages everything from the kitchen to the ingredients to the final product. You just eat the pizza. See, when you break it down like that, it's not so complicated after all. Each level simply represents a different degree of management and control. From IaaS, where you control a lot, to SaaS, where you control almost nothing and just use the product. Understanding this as a service model is the key to unlocking the entire cloud computing landscape. Now that we know what kinds of services are offered, the next logical question is, where are they offered? Is the cloud just one giant global computer that everyone shares? Or can a company have its own private, exclusive cloud? The answer is yes to all of the above. And that leads us directly into the three main ways the cloud is deployed: public, private, and hybrid. Each one serves a very different purpose, and understanding the difference is crucial for businesses and even for you as a consumer. Let's start with the one you interact with every single day, whether you realize it or not: the public cloud. Think of the public cloud like a massive, professionally managed apartment complex. The building itself, the foundation, the plumbing, the electricity, the security at the front door, is owned and operated by a huge company, a landlord. In the world of cloud, these landlords are giants like Amazon with Amazon Web Services, or AWS, Microsoft with Azure, and Google with Google Cloud Platform. They build and maintain these colossal data centers, these digital apartment buildings all over the world. Now, you, as a tenant, whether you're a solo app developer or a massive company like Netflix, can rent an apartment or a server in this building. You don't own the building. You don't have to worry about fixing the roof when it leaks or upgrading the electrical grid. You just pay your rent for the space you use. And the best part? If you suddenly have 100 friends coming over, you can instantly rent the apartment next door for the night. The next day when they're gone, you stop paying for it. This is called scalability and elasticity, and it's the public cloud superpower. Imagine you're a startup with a brilliant idea for a new photo sharing app. In the old days, you'd have to go out and buy a bunch of expensive servers, find a place to store them, hire people to manage them, and hope you bought enough to handle your launch day traffic. But what if your app wasn't a hit? You'd be stuck with thousands of dollars of useless, depreciating hardware. But if your app went viral beyond your wildest dreams, your servers would crash, your users would get angry, and your moment would be lost. It was a high-stakes guessing game. With the public cloud, that startup can rent a tiny cheap server, a studio apartment, for just a few dollars a month. As more users sign up, they can automatically rent more servers, a second apartment, then a third, then a whole floor of the building, all in a matter of minutes. If 1 million people sign up overnight, the cloud can handle it. The app scales seamlessly, and the startup only pays for exactly what they use, a model called pay-as-you-go. This is why the public cloud has been the engine of innovation for the last decade. It democratized computing power. It allowed small companies with big ideas to compete with giants because they could access the exact same world-class infrastructure without the crippling upfront cost. When you're streaming a movie on Netflix or listening to a playlist on Spotify, you're using the public cloud. They don't own the millions of servers needed to deliver that content to you. They rent that capacity from a public cloud provider. But like living in an apartment building, there are trade-offs. You share the building's resources with other tenants. While you have your own locked apartment, you're all using the same hallways, elevators, and water pipes. In the cloud, this is called a multi-tenant environment. For the vast majority of users, this is perfectly fine and secure. But sometimes a noisy neighbor, another company on the same physical hardware using a ton of resources, can potentially affect your performance. More importantly, for some organizations, the public cloud just doesn't offer enough control or meet their strict security and regulatory requirements. And that brings us to the private cloud. If the public cloud is an apartment complex, the private cloud is your own custom-built, single-family home. You own the land, you designed the blueprint, and you built the house from the ground up. You control everything. You choose the locks for the doors, the type of wiring in the walls, and the color of the paint. Nobody else lives there. This is the private cloud. It's computing infrastructure that is dedicated exclusively to one organization. It's not shared with anyone else. This house can be physically located in your own backyard, that is, in a company's on-site data center, or it can be hosted by a third-party service provider. But the key is that all the hardware and software are for your organization's use alone. So who needs this level of exclusivity and control? Think about organizations that handle incredibly sensitive data. A major bank, for instance. They have to comply with strict financial regulations about how and where customer data is stored. They can't just put their core banking systems on a shared public server next to a video game company. They need to know exactly where their data is, who has access to it, and that it's protected by their own specific security protocols. They need to build their own fortress. Similarly, a government intelligence agency or a hospital handling private patient records will almost always opt for a private cloud for their most critical information. They need the highest level of security and the ability to customize their environment to meet very specific compliance standards, like HIPAA for healthcare in the US. The benefits are clear: unparalleled security and control. You can tailor every single aspect of the infrastructure to your exact needs. But just like owning a custom-built house, the downsides are significant. First, the cost. It is incredibly expensive. You have to buy all the hardware yourself, the servers, the networking gear, the storage. This is a massive capital expenditure, or CapEx. Then you have to pay for the real estate to house it, the electricity to run it, and the cooling to keep it from overheating. And most importantly, you need to hire a team of highly skilled IT professionals to build, maintain, and secure it 24/7. You are the landlord now. If the plumbing breaks at 3 a.m., you're the one getting the call. It's a huge responsibility. It also doesn't have that same instant, infinite elasticity of the public cloud. If you need more capacity, you can't just click a button. You have to physically buy and install more servers, which takes time and money. So, on one hand, you have the public cloud, incredibly flexible, cost-effective, and scalable, but with less control. On the other, you have the private cloud. Highly secure, customizable, and controlled, but expensive and complex. For years, businesses felt they had to choose. But what if you could have the best of both? What if you could live in your secure, private house but also have access to the city's massive, efficient public power grid when you need extra juice? That is the entire idea behind the hybrid cloud. The hybrid cloud is exactly what it sounds like: a strategic combination of a private cloud and a public cloud. The two environments are linked together, allowing data and applications to be shared between them. It's not about choosing one over the other. It's about using the right tool for the right job. Let's go back to our analogies. Imagine you own your secure private house, your private cloud, where you keep all your most valuable and personal belongings, family heirlooms, important documents. You're safe. But you also rent a cheap, flexible storage unit down the street, the public cloud, for things you don't need every day, like seasonal decorations or old furniture. You get the security of your home for what matters most, and the cost-effective convenience of the storage unit for everything else. Here's a perfect business example. A large online retailer. They have a massive database of customer information, names, addresses, credit card numbers. This is their crown jewel. They're going to keep that sensitive data locked down tight in their own private cloud, where they have total control over security. However, their public-facing website, the one you shop on, needs to handle unpredictable traffic. Most of the year, traffic is normal. But then comes Black Friday. Suddenly, millions of shoppers flood the site at once. Their private cloud servers, built for normal traffic, would instantly melt. Instead of buying millions of dollars in extra servers that would sit idle for 364 days of the year, they use the hybrid model. They keep the customer database secure on the private cloud, but when the Black Friday traffic spike hits, their application bursts into the public cloud. They can spin up thousands of temporary servers on AWS or Azure almost instantly to handle the load, paying only for the few hours or days they need them. Shoppers get a smooth experience, the retailer makes a ton of money, and once the rush is over, they scale back down and the public cloud resources vanish. This cloud bursting is a classic use case for hybrid cloud. Another is disaster recovery. A company might run its daily operations in its private cloud, but continuously back up its data to the public cloud. If a fire or a flood takes out their primary data center, they can quickly switch over and run their business from the cloud, ensuring they stay online. The hybrid cloud offers incredible flexibility. It allows organizations to modernize their technology at their own pace. They can keep their old legacy systems running on their private cloud while building new, innovative applications in the more agile public cloud. It's about optimizing cost, security, and performance by placing workloads in the environment where they make the most sense. The challenge, of course, is complexity. Now you're managing two different environments and making them talk to each other seamlessly and securely. It requires careful planning and sophisticated management tools to pull off effectively. But for many large enterprises, this blend of security and flexibility is the undisputed sweet spot. So now that we have a map of the cloud landscape, the public, the private, and the hybrid, we need to talk about what you actually do there. It's one thing to know where the kitchen is, it's another thing entirely to know what's on the menu. Because the cloud isn't just one thing. It's a spectrum of services, a tiered offering that lets you choose exactly how much you want to control and how much you want someone else to handle for you. To understand this, we're going to use what is probably the most famous and frankly the most perfect analogy in all of tech: pizza as a service. Stick with me here. Imagine you want pizza. You have a few options. Option 1. The traditional do-it-yourself method. You make it all from scratch. You go to the store, buy the flour, the yeast, the tomatoes, the cheese, the pepperoni. You come home, you make the dough, you proof it, you make the sauce, you grate the cheese. You turn on your oven, which you own and pay the electricity for. You use your own pans, your own table, your own sodas. You have total absolute control over every single ingredient and every step of the process. This is the old way of doing IT, what we call on-premise. You own the servers, you manage the electricity and cooling, you install the operating systems, you manage the databases, you write the code. You control everything. It gives you maximum control, but it's also the maximum amount of work. Now let's enter the world of as a service. Option 2. You decide you don't want to make the dough and the sauce from scratch. So you go to the store and buy a take-and-bake pizza. The pizza place has handled the core ingredients and assembly. They've provided the dough, the sauce, the toppings all put together. But you still have to take it home, use your own oven, your own electricity, your own plates, and your own drinks. You're outsourcing the foundational infrastructure of the pizza, but you're still managing the platform it gets cooked and served on. This is infrastructure as a service, or IaaS. IaaS is the most basic, fundamental building block of the cloud. With IaaS, a cloud provider like Amazon Web Services, Microsoft Azure, or Google Cloud gives you the raw computing ingredients: virtual servers, storage, and networking. It's like renting a portion of their massive world-class kitchen. You get access to the oven, the fridge, and the counter space, but you're in charge of everything else. You have to install your own operating system, Windows or Linux. You have to install your database software, manage all the security patches, and deploy your own applications. You're not buying the physical server hardware, you're not building the data center, you're not managing the cooling or the physical security, but you are responsible for almost everything on the software side. This gives you a ton of flexibility. If you have a very specific custom application that needs a particular version of an operating system and finely tuned network settings, IaaS is your go-to. You have near total control over the digital environment without having to own a single physical server. It's the ultimate take-and-bake model for businesses that need that granular control. Okay, let's go back to our pizza night. Option 3. You're even hungrier and less patient. You don't want to deal with preheating your own oven and waiting for the pizza to cook. So you order for delivery. The pizza place takes care of everything: the ingredients, the assembly, and the cooking. They use their specialized super hot pizza oven to make it perfect. All you have to do is provide the table, the plates, and the drinks. The finished product arrives at your door, hot and ready. You've offloaded even more of the work. This is platform as a service, or PaaS. PaaS is the next level up the cloud stack. The cloud provider manages the infrastructure, the servers, the storage, the networking, ***. They also manage the underlying platform. This includes the operating system, the database management system, and the development tools. It's a complete, ready-made environment for developers to build, test, and deploy software applications without ever having to worry about the underlying infrastructure. Think of it this way: with IaaS, you get an empty kitchen you have to set up. With PaaS, you get a fully equipped, functioning kitchen where all the basic ingredients are already prepped and waiting. All you, the developer, have to do is come in with your unique recipe, your application code, and start cooking. You focus purely on writing the code that makes your app special, not on patching the server's operating system or configuring a database. Services like Heroku, Google App Engine, and AWS Elastic Beanstalk are classic PaaS examples. You just upload your code, and the platform handles the rest, deploying it, managing traffic, and even scaling it up automatically if your app suddenly goes viral. It's an incredible accelerator for innovation. And that brings us to our final pizza scenario. Option 4. You don't even want to set the table. You don't want to deal with plates or drinks or cleanup. You just want to eat pizza. So you go out to a restaurant. You walk in, sit down, order, and a finished, perfectly cooked pizza is brought to your table on a plate. You eat it, you pay the bill, and you walk away. The restaurant handled literally everything. The building, the staff, the oven, the ingredients, the cooking, the serving, the plates, the cleanup. You are just a consumer of the final product. This is software as a service, or SaaS. SaaS is the model of cloud computing you are almost certainly using every single day, whether you realize it or not. It's a fully baked, ready-to-use software application that you access over the internet, typically through a web browser. When you use Gmail, you're using SaaS. You don't manage the email servers, the software updates, or the spam filters. Google does. You just log in and use it. When a company uses Salesforce for its customer management, that's SaaS. When you stream a movie on Netflix, you're using a massive, sophisticated SaaS platform. Microsoft 365, Dropbox, Slack, it's all SaaS. With SaaS, you manage nothing. You don't own the software, you just subscribe to it, usually for a monthly or annual fee. The provider is responsible for everything: the infrastructure it runs on, the platform it's built on, and the software application itself, including all the updates, maintenance, and security. You are purely an end user. It's the ultimate inconvenience. You get access to powerful enterprise-grade software without any of the headache of maintaining it. So let's quickly recap this pizza-powered pyramid of cloud services. At the bottom, giving you the most control but requiring the most work, is infrastructure as a service, IaaS. The cloud provider manages the physical hardware. You manage everything else from the operating system on up. This is your take-and-bake pizza. In the middle is platform as a service, PaaS. The cloud provider manages the hardware and the operating platform. You just manage your application and its data. This is your delivered pizza. And at the top, offering the most convenience but the least control, is software as a service, SaaS. The cloud provider manages everything. You just log in and use the software. This is dining out at the pizza restaurant. IaaS, PaaS, and SaaS. These three models form the core of what the cloud offers. They are not competing against each other. They are different tools for different jobs. And here's the critical part. A single company, even a single person, might use all three simultaneously. A startup might use a SaaS product like Google Workspace for their email and documents. Their developers might be building their unique application on a PaaS like Heroku to get to market quickly. And they might be running a heavy-duty data analytics engine on a cluster of IaaS virtual machines from AWS for maximum power and control. It's a flexible, layered approach. Understanding this stack, from the raw infrastructure to the ready-made software, is the key to unlocking the true power and vocabulary of the cloud. It's how you move from just knowing the cloud exists to understanding what you can actually build with it. And what companies are building is nothing short of revolutionary. And to understand that revolution, we don't need to look at a complex algorithm or a line of code. We need to look at something much simpler. We need to talk about pizza. Imagine you decide to start a world-class pizza business. Not just a corner shop, but an empire. In the old world, before the cloud, here's what you'd have to do. First, you need a building. So you buy or lease a property. Then you need a professional kitchen. You'd buy the ovens, the refrigerators, the mixers, the prep tables. You'd have to get the gas lines installed, the electricity upgraded, the plumbing sorted out. You'd buy the flour, the yeast, the tomatoes, the cheese. You'd hire the chefs, the delivery drivers, and the staff to maintain the ovens and clean the kitchen. You are responsible for everything, from the foundation of the building to the final delivered slice. This is a massive upfront investment of time and money. If your pizza becomes a viral sensation overnight, you can't just instantly build a second kitchen. takes months. If you have a slow season, those expensive ovens are still sitting there, taking up space and depreciating in value. This entire self-contained, capital-intensive model is what we call on-premise in the tech world. You own and manage everything yourself on your own property. For decades, this was the only way to run a serious software company. You bought your own servers, you built your own server rooms with special cooling and security, and you hired armies of people to manage it all. But then the cloud introduced a new way of doing things. It introduced the as-a-service model. Let's go back to our pizza empire. What if you could skip building the kitchen? Imagine there's a company that owns a massive state-of-the-art commercial kitchen. They let you rent out a section of it by the hour. They handle the building, the power, the gas, the security, and they provide the ovens, the fridges, and the counter space. All you have to do is show up with your ingredients, your secret recipe sauce, your premium cheese, your artisan dough, and your chefs. You get to use their top-of-the-line equipment to cook your pizza your way. You control the recipe, the cooking time, the quality. You just don't have to own the physical kitchen. If you suddenly get 1,000 orders, you just rent more oven space. If it's a slow night, you power down and pay less. This is infrastructure as a service, or IaaS. It's the most basic layer of cloud computing. You are renting the fundamental infrastructure, the virtual servers, the storage, the networking, from a cloud provider like Amazon Web Services, Microsoft Azure, or Google Cloud. Companies use IaaS to rent the virtual equivalent of those ovens and fridges. They get raw computing power, but they still have to bring their own chefs and ingredients. That means they're responsible for managing the operating system, the databases, and the applications themselves. They're just outsourcing the hardware headache. This gives them a ton of flexibility and control, without the crippling upfront cost of building their own data center. Okay, but what if you want to simplify even further? You're a pizza artist. You're obsessed with creating the world's most innovative flavor combinations, not with managing oven temperatures or cleaning schedules. So you find a different kind of service. This service not only provides the kitchen and the ovens, but they also provide the basic ingredients: high-quality dough, a standard tomato sauce, and mozzarella cheese. They even have staff that will manage the cooking process for you. All you have to do is show up with your unique special toppings, your prosciutto and fig, your spicy honey, your truffle oil, and tell them how to assemble it. You focus purely on your unique value, your recipe, and they handle almost everything else. This is platform as a service, or PaaS. With PaaS, the cloud provider manages the infrastructure and the underlying platform, the operating systems, the development tools, the database management. A software developer, our pizza artist, can just bring their application code, their secret recipe, and deploy it without ever worrying about server maintenance or software updates. The platform handles all of that messy, undifferentiated work. This allows developers to build and launch applications incredibly fast because they can focus on writing code, not on managing infrastructure. Services like Heroku or Google App Engine are classic examples. It's a workshop where all the tools and raw materials are ready and waiting for the creator to do their unique work. You get less control than with IaaS. You have to use their dough and their ovens, but you gain a massive amount of speed and convenience. Now for the final and most common level. You decide that you don't want to make pizza at all. You love pizza, you're an expert on what makes a good pizza, and you want to build a business around selling it. But the whole making it part? You want someone else to handle that. So you just pick up the phone or open an app, and you order a fully cooked, perfect pizza delivered right to your door. You don't know what kind of oven they used. You don't know who their flour supplier is. You don't care. You just want the finished product ready to consume. This is software as a service, or SaaS. This is the layer of the cloud you interact with every single day. SaaS is a fully finished application that you access, usually through your web browser. Think about it: Gmail. You don't manage the email servers, you don't install the software, you don't worry about the underlying infrastructure. You just log in and use it. Netflix is SaaS. You don't manage the video files or the streaming servers. You just press play. Salesforce, Dropbox, Slack, Microsoft 365, these are all SaaS products. You are renting the finished software, the delivered pizza. It offers the ultimate convenience but the least amount of control. You can't change how Gmail works. You can only use it as Google intended. So we have these three layers. IaaS, the foundation, is renting the empty kitchen. PaaS, the middle layer, is renting a workshop where the basic materials are provided. And SaaS, the top layer, is ordering the finished, delivered product. Each layer represents a trade-off between control and convenience. The more you move up the stack from IaaS to PaaS to SaaS, the more work you offload to the cloud provider, but the less control and customization you have. A huge, sophisticated company like Netflix might use IaaS because they need granular control over their massive video streaming infrastructure to optimize performance down to the millisecond. A fast-moving startup might use PaaS to get their new app to market in weeks instead of months, without hiring a huge operations team. And almost every company in the world and every person listening to this uses SaaS for things like email, file storage, and collaboration because it just doesn't make sense to build those things from scratch anymore. Understanding this stack, infrastructure, platform, and software as a service is like being handed the master key to the entire cloud. It's the vocabulary that describes what is actually being bought and sold in this multi-trillion-dollar industry. It's not just some fuzzy abstract cloud. It's a specific set of services that offer different levels of management and control. But this raises the most important question of all. We see the what, but why? Why did this entire as-a-service model take over the world? What was so fundamentally broken about the old on-premise way of doing things that it forced even the biggest, most successful companies to abandon their own expensive data centers and bet their entire future on renting someone else's? The answer isn't just about convenience or cost. It's about survival. It's a story of explosive, unpredictable demand, catastrophic failures, and one brilliant, counterintuitive idea that changed how all modern technology is built. To understand this revolution, we have to go back to the early 2000s. And we have to talk about Amazon. Not the Amazon of today, the unstoppable global behemoth. No, this was a younger, scrappier, and far more fragile Amazon. They were known for one thing, selling books online. But they were growing at a terrifying pace, expanding into music, electronics, and more. And their technology was screaming. It was a chaotic mess of different teams, different software, and different databases, all cobbled together. Imagine a dozen different construction crews all trying to build one skyscraper, but none of them are using the same blueprint. Some are using metric, some are using imperial, and nobody is talking to each other. That was Amazon's internal infrastructure. Every year, this ticking time bomb would get dangerously close to detonating during the holiday shopping season. Black Friday, Cyber Monday. For us, it's a time for deals. For Amazon's engineers back then, it was a time of sheer terror. The website would slow to a crawl. Pages would fail to load. The Add to Cart button would become a button of pure hope and prayer. Behind the scenes, it was all hands on deck. A frantic scramble to keep the digital lights on. Engineers were sleeping in the office, manually moving workloads around, trying to prevent a total catastrophic meltdown that would not only cost them billions in sales, but could permanently shatter customer trust and destroy the company. They had a massive fundamental problem. To prepare for the holiday rush, they had to buy a staggering number of servers. An entire army of computers that would sit there, humming away, drawing power and costing a fortune. But here's the kicker. They only needed that massive capacity for a few weeks out of the entire year. For the other 11 months, most of those expensive, powerful servers sat idle, gathering dust, doing virtually nothing. It was like buying an entire fleet of 18-wheelers just to move apartments once a year. It was astronomically expensive and breathtakingly inefficient. The bigger problem, though, was speed. When a new team at Amazon wanted to launch a new feature, say a new recommendation engine, they had to start from scratch. They had to submit a request for servers, wait for them to be ordered, delivered, racked, and configured. This process could take weeks, sometimes months. Innovation was grinding to a halt, choked by the very infrastructure that was supposed to enable it. Amazon was a technology company that was being slowly killed by its own technology. Then, in 2003, a couple of engineers, Benjamin Black and Chris Pinkham, wrote a paper, a vision document. They looked at the absolute chaos and saw a pattern. They realized that every single team inside Amazon was wasting most of its time solving the exact same basic problems over and over again. Everyone needed computing power. Everyone needed storage. Everyone needed a database. Yet everyone was building their own, slightly different, and totally incompatible solutions. The paper proposed a radical, counterintuitive idea. What if they stopped doing that? What if, instead of every team building their own little tech silos, they created a central internal service that provided these core components as standardized building blocks? Imagine if instead of every construction crew having to make their own bricks, their own mortar, their own steel beams, there was a central warehouse that could provide any team with any number of bricks, any amount of mortar, instantly, on demand. This was the brilliant idea. To turn their own infrastructure into a utility, a service that any developer inside Amazon could use, just like flipping on a light switch. They wouldn't need to know where the power plant was or how the electricity was generated. They just plug in and get the power they needed. This internal project was designed to solve Amazon's own crippling problems. They built it, and it worked. It worked spectacularly well. Teams could now spin up the resources they needed in minutes, not months. They could experiment, they could build, they could innovate at a speed that was previously unimaginable. They had solved their survival problem, but then came the truly world-changing leap of logic. As they stood back and looked at the incredibly powerful, reliable, and scalable computing platform they had built for themselves, someone somewhere asked a question that was worth $1 trillion. We've become the best in the world at running massive-scale computer infrastructure. What if we let other people use it too? What if we rented out our excess capacity? What if we sold access to our internal utility to the rest of the world? In 2006, they did just that. They launched Amazon Web Services, or AWS. And they didn't just rent out servers. They broke down the concept of a data center into its most fundamental components and offered them as individual services. First, there was S3, the simple storage service. This was, and is, essentially an infinite hard drive in the sky. You could store any amount of data, from a single photo to petabytes of scientific research, and only pay for what you used. Then came EC2, the elastic compute cloud. This was the real game changer. This was the ability to rent a virtual computer, a slice of one of Amazon's powerful servers, by the hour. You didn't need to buy a physical machine. You could just go to a website, click a few buttons, and within minutes, have a brand new, clean, powerful virtual server running anywhere in the world. And when you were done with it, you could just turn it off and stop paying. This was the birth of what we now call infrastructure as a service, or IaaS. It's the foundational layer of the cloud. It's the Lego bricks. IaaS is when a cloud provider like Amazon, Microsoft, or Google gives you the raw ingredients of computing, the virtual servers, the storage, the networking. They manage the physical data center, the cooling, the power, the security, and the broken hardware. But you are responsible for managing everything on top of that: the operating system, the software, the code. You're renting the empty plot of land and the pile of bricks. You still have to build the house yourself, but you don't have to build the factory that makes the bricks. This single idea completely rewrote the rules of business and technology. Remember that problem of buying servers for Black Friday that sit idle all year? EC2 solved it with a concept called elasticity. You could now programmatically spin up 10,000 servers on Thanksgiving night to handle the traffic, and then automatically shut them all down on New Year's Day. You only paid for that peak capacity when you actually used it. The economic waste of idle servers vanished overnight, and the problem of waiting months for new hardware? Gone. A startup with a great idea, run by two people in a garage, no longer needed to raise $5 million in venture capital to buy their own data center. For the price of a few pizzas, they could rent a supercomputer for an afternoon, test their idea, and if it didn't work, shut it down. If it did work, they could scale to millions of users without ever having to buy a single physical server themselves. This is the secret power of the cloud that no one talks about. It's not just about convenience. It was a profound democratization of technology. It leveled the playing field, giving the smallest startups access to the same world-class, industrial-strength infrastructure that was previously only available to the biggest corporations on Earth. Suddenly, your ability to succeed wasn't limited by how much money you had for hardware. It was limited only by the quality of your ideas and your ability to write code. This is why we saw an explosion of new internet companies like Netflix, Airbnb, Slack, and Pinterest in the years that followed. Almost all of them were built on the back of AWS. They couldn't have existed without it. But renting raw infrastructure, these virtual servers and hard drives, was still pretty complicated. It was a massive leap forward, but it was still for the experts, the system administrators, the hardcore engineers who knew how to build a house from a pile of bricks. To truly unlock the power of the cloud for everyone, the next step had to be even simpler. The cloud had to evolve beyond just providing the raw materials. It needed to start providing the finished product. And this is where the cloud has its most profound, most visible, and most personal impact on all of our lives. This is the layer of the cloud you use every single day, probably every single hour, even if you don't know it. We're talking about the final piece of the puzzle: software as a service, or SaaS. If infrastructure as a service, or IaaS, was the plot of land and the pile of raw materials, and platform as a service, or PaaS, was the pre-built frame, the plumbing, and the electrical wiring, then software as a service is the fully furnished, move-in ready house. The key is already in the door. You don't need to be a builder or an architect. You don't need to know how the foundation was poured or how the circuits were wired. You just walk in, flip the light switch, and start living your life. The utility company takes care of the rest. This is software as a service. It's finished software, delivered to you over the internet, ready to use. You don't buy it in a box. You don't download a massive installation file. You don't worry about updates or patches, or whether your computer is powerful enough to run it. You just open your web browser or an app on your phone, log in, and it works. Think about the most common things you do online. Checking your email with Gmail? That's SaaS. You didn't set up a mail server in your basement. You didn't configure storage arrays to hold your messages. You just created a Google account, and instantly you had access to a world-class email system. Google manages the billions of emails, the petabytes of data, the global network of servers, the security that stops spam and viruses, all of it completely invisible to you. You are renting a finished service. Watching a movie on Netflix? That's SaaS. You don't own a single movie file. You don't manage a complex video streaming server that can handle millions of simultaneous viewers. You just pay your monthly subscription, press play, and the movie appears. Netflix handles the content licensing, the video compression, the massive infrastructure required to stream high-definition video to the entire planet. They are providing the entire entertainment experience as a service. This model completely flipped the entire software industry on its head. For decades, the model was simple. You bought a product. You went to a store, bought a box containing a CD-ROM for Microsoft Office, you went home, you installed it, and you owned that specific version of that software forever. It was a one-time transaction, but it was also your problem. If a new version came out with critical features, you had to go buy it again. If you got a new computer, you had to find the disk and the license key to reinstall it. If your hard drive crashed, you might lose everything. Software as a service changed the entire relationship from ownership to access. Instead of paying $300 upfront for Microsoft Office, you now pay $10 a month for Microsoft 365. For that small recurring fee, you get access to the software on your laptop, your phone, your tablet. You always have the latest, most secure version because it's updated automatically in the background. Your documents aren't just stuck on one computer. They're saved in the cloud on OneDrive, accessible from anywhere. The company providing the software wins because they get a predictable, steady stream of revenue instead of lumpy, one-time sales. And the user wins because the barrier to entry is incredibly low. You don't need hundreds of dollars to get a professional tool. You just need a few dollars for this month's access. This seemingly simple change in the business model had a domino effect that created the modern internet as we know it. Think about all the services that define our digital lives. Listening to music on Spotify, storing and sharing files with Dropbox, collaborating on documents with Google Docs, chatting with colleagues on Slack, managing customer relationships with Salesforce. Every single one is a SaaS application. The beauty and the genius of this model is that it hides all the complexity we've been talking about. It takes the raw computing power of IaaS and the developer-focused tools of PaaS and wraps them up in a simple, user-friendly package. Here's the secret. Almost every major SaaS company is a massive customer of the other cloud layers. For years, Netflix was famously one of the biggest customers of Amazon Web Services. They didn't want to be in the business of building and managing data centers. They wanted to be in the business of streaming movies. So they built their incredible software platform, their service, on top of Amazon's global infrastructure. They let Amazon handle the land and bricks, so they could focus on building the best finished house. This creates the three fundamental layers of the cloud computing stack. At the very bottom, you have infrastructure as a service, the raw servers, storage, and networking. It offers the most flexibility and control, but requires the most expertise. It's for the system architects. In the middle, you have platform as a service, the operating systems, databases, and development tools. It abstracts away the hardware, letting developers focus purely on building their applications without worrying about the underlying infrastructure. And at the very top, you have software as a service, the finished applications that are delivered to the end user. This layer abstracts away everything. The user doesn't need to know anything about servers, code, or databases. They just need to know what they want to accomplish. Each layer is built on the one below it like a pyramid. SaaS is built on PaaS and PaaS is built on IaaS. This is why the cloud is so powerful. It provides different levels of service for different needs. But the true revolution of SaaS wasn't just about convenience for individuals. It was about the democratization of power for businesses. Before the cloud, if you wanted to start a company, you needed a massive amount of capital upfront. You had to buy servers, you had to license expensive software for accounting, for customer management, for everything. A small startup was at a huge disadvantage compared to an established giant. SaaS completely leveled the playing field. Suddenly, A two-person startup operating out of a garage could pay a monthly fee and get access to the exact same powerful enterprise-grade tools as a Fortune 500 company. They could use Salesforce for their customer data, Google Workspace for collaboration, and Slack for communication, all for a predictable, manageable operating expense instead of a crippling upfront cost. This unleashed a wave of innovation unlike anything we had ever seen. Entrepreneurs could now build and scale businesses faster and cheaper than ever before. The cloud, and specifically the SaaS model, is the engine that powered the last 15 years of technological disruption, from tiny mobile app startups to global giants like Airbnb and Uber. This is the ultimate fulfillment of that 60-year-old vision of computing as a utility. When you flip a light switch, you don't think about the power plant, the transformers, or the high-voltage lines. You just get the light you need. In the same way, when you log into your email or open a shared document, you're tapping into a global utility of immense power and complexity. You're using the cloud, the most visible, most accessible, and most transformative layer of it all. It's a finished product delivered as a service that has fundamentally rewired the way we work, play, and connect with one another. So now we have the complete picture: the raw infrastructure, the developer platforms, and the finished software. But this whole system, this global computer, is handling an unimaginable amount of our personal and corporate data. So who is actually responsible for keeping it all safe? When you hand your data over to the cloud, who is locking the door at night? The answer to that question isn't a single name or a single company. It's a concept, a pact, known in the industry as the shared responsibility model. And understanding this one idea is the most important thing you need to know about cloud security. Think of it like renting a high-security storage unit. The company that owns the facility is responsible for the big stuff: the concrete walls, the steel doors, the 24/7 surveillance cameras, the barbed wire fence, and the guard at the gate. They are responsible for the security of the facility. But you are responsible for what you put inside your unit. You're responsible for using a strong lock on your door, and you're responsible for not leaving the key under the welcome mat. That's security in the facility. The cloud is the exact same. The cloud provider, Amazon, Google, Microsoft, they are responsible for the security of the cloud. You, the customer, are responsible for security in the cloud. This division of labor is the bedrock of how this entire global system stays safe. Let's start with their side of the bargain: the security of the cloud. And I want you to understand, this is a level of security that borders on science fiction. It makes most bank vaults look like piggy banks. The physical data centers themselves are often anonymous buildings in undisclosed locations. They are fortresses. We're talking perimeter fences with anti-climb technology, vehicle crash barriers, and platoons of professional security guards on patrol 24/7/365. To get inside, you have to pass through multiple checkpoints. First, maybe an ID scan at the gate. Then you enter a man-trap, a small chamber with two interlocking doors, where only one can be open at a time. Inside, you face biometric scanners, fingerprints, iris scans, sometimes even vein pattern recognition. Every single person's movement is tracked from the moment they step on the property. And that's just to get into the building. The server rooms themselves, the data halls, have their own additional layers of biometric access control. The servers are in locked cages. The hard drives themselves are often encrypted by default, and when they are retired, they aren't just wiped. They are physically destroyed, shredded into tiny pieces by industrial-grade machinery, all while being videotaped to prove it was done. These facilities also have redundant power from separate utility grids, massive diesel generators for backup, and sophisticated fire suppression systems that can extinguish a fire without using water that would destroy the electronics. They are built to withstand natural disasters. This is their promise. The physical hardware that runs the cloud will be protected with a level of resources that 99.9% of companies on Earth could never dream of affording on their own. Beyond the physical, they are also responsible for securing the network. They employ armies of the world's best cybersecurity experts whose only job is to fend off attacks. They build massive global networks with built-in defenses against things like distributed denial of service or DDoS attacks. A DDoS attack is essentially digital mob rule. It's when hackers use thousands of infected computers to all try and access a single website at the exact same moment. It's like 10,000 people trying to cram through a single revolving door. It brings everything to a grinding halt. Cloud providers have built their networks to be like a stadium with 1,000 gates. They can absorb these massive traffic spikes and use sophisticated software to identify and block the malicious traffic before it ever reaches the customer's application. They also handle patching the core infrastructure, ensuring the fundamental software that manages all those virtual machines is always up to date and protected from the latest known vulnerabilities. They spend billions of dollars a year on this. Their entire business model depends on being trustworthy. This is their half of the deal. But now we have to talk about your half. Security in the cloud. Because this is where almost all cloud-related data breaches happen. Not from a James Bond-style heist on a data center, but from a simple mistake. A digital key left under the doormat. One of the most common services in the cloud is object storage, like Amazon's S3. It's basically an infinitely large hard drive on the internet where companies can store files. They call these storage spaces buckets. By default, these buckets are completely private and locked down. But with a few clicks, a developer can make a bucket public so that, for example, images on a website can be easily accessed by anyone. And this is where the disaster happens. Countless major data breaches have occurred because an employee accidentally configured a bucket containing sensitive customer data, names, addresses, financial records, to be public. The bucket was leaky. It wasn't Amazon's fault. Their facility was secure. The customer left their storage unit door wide open for the whole world to see. This is the core of the customer's responsibility. Configuration. You are responsible for configuring the services you use correctly. This also includes managing who has access to your cloud accounts. This is called Identity and Access Management, or IAM. Think about it. You wouldn't give every employee in your company the master key to the CEO's office. You give people access only to the resources they need to do their job. This is the principle of least privilege. In the cloud, you can create incredibly granular rules. You can say, this marketing account can upload files to the marketing folder, but it can't delete anything, and it absolutely cannot access the financial database. Setting this up correctly is your job. If you give an intern administrator access and they accidentally delete your entire customer database, that's not the cloud provider's fault. Then there's data encryption. While the provider might encrypt the physical hard drives, you are often responsible for encrypting your data within their services. There are two critical types. First is encryption in transit. This means that when data is traveling from your computer to the cloud, it's scrambled. This is what HTTPS does, the little lock icon in your browser. It creates a secure tunnel, so even if someone is snooping on the Wi-Fi at your coffee shop, all they see is gibberish. The second is encryption at rest. This means that even after the data arrives and is sitting on the server, it remains in a scrambled state. To unlock it, you need a specific cryptographic key which you, the customer, control. So even if a rogue employee at the data center somehow managed to get their hands on a hard drive containing your data, it would be completely unreadable to them. Deciding if, when, and how to apply this encryption is your responsibility. Finally, if you're using the more fundamental cloud services like a raw virtual machine and infrastructure as a service offering, you are responsible for everything on that machine. You have to install security patches for the operating system, just like you do for Windows on your laptop. You have to make sure the applications you install are secure. You have to set up the firewall rules. The cloud provider gives you a secure, empty plot of land. You are responsible for building a secure house on top of it. So this is the pact. The cloud providers build a digital Fort Knox, a platform with security capabilities far beyond what most could achieve on their own. But they hand you the keys. They give you all the tools, the locks, the alarms, the access lists, but you have to use them correctly. It's a partnership. They can build the safest car in the world, with airbags, crumple zones, and automatic braking. But if you choose to text while driving it at 100 miles an hour, they can't stop the inevitable crash. The power of the cloud is immense, and so is the responsibility that comes with it. This shared model makes the cloud incredibly secure when used correctly, but it also means the weakest link is often not the technology, but the person configuring it. So the cloud can be incredibly secure, often more secure than a company's own private data center. But this shared responsibility model also introduces new complexities. And when things go wrong, they can go wrong at a catastrophic scale. What happens when the cloud itself fails? And what does the future of this global brain actually look like? The question isn't theoretical. It's happened. December 7, 2021. For millions of people across the United States, it felt like the internet just broke. Your Ring doorbell suddenly went offline. Your iRobot vacuum cleaner stopped in the middle of the living room floor. You couldn't order from DoorDash, stream on Disney+, or trade stocks on Robinhood. Even Amazon's own delivery drivers found themselves stranded, their routing apps completely dead, unable to scan packages or find their next stop. It was chaos, but a quiet digital kind of chaos. What was the culprit? Not a massive solar flare or a coordinated cyber attack. It was a single automated process gone wrong inside one of the most important buildings on the planet, an Amazon Web Services data center known as US East 1, located in Northern Virginia. This one region is so critical, so foundational to the modern internet, that its failure caused a catastrophic cascade effect. It was a stark reminder that the cloud, for all its abstract ethereal branding, is a physical thing. It's buildings and servers and networks and code written by humans. And physical things, engineered things, can fail. This event and others like it forced a global reckoning. The promise of the cloud was infinite reliability. The reality was that concentrating so much digital infrastructure in one place, even a massive redundant place like a data center region, creates a single point of failure. In the aftermath, the entire industry doubled down on a concept called designing for failure. The goal is no longer to prevent failure entirely, because that's impossible. The goal is to build systems that can withstand failure. This is where you hear terms like multi-region redundancy. A company like Netflix doesn't just run its service out of one AWS region. They run it simultaneously across multiple regions around the world. If the entire East Coast of the United States goes dark digitally, their system is designed to automatically reroute all traffic to servers in Ohio, or Oregon, or even Ireland, without the user ever noticing a flicker in their movie. It's like having multiple independent power grids for your house. If one goes down, another one instantly kicks in. This approach is incredibly expensive and complex, but it's the price of true resilience. The cloud isn't a magical, unbreakable entity. It's a series of interconnected, man-made systems, and its strength comes from acknowledging its potential for weakness and architecting around it. The cloud is constantly evolving, learning from its mistakes, and becoming more like a biological organism. A global network that can heal itself, reroute around damage, and keep functioning even when parts of it fail. But this evolution isn't just about becoming more resilient. It's about becoming something fundamentally different. The cloud we've described so far, these giant centralized data centers, is really just Cloud 1.0. We are now rapidly moving into the next era. An era where the cloud is no longer a destination, but a pervasive fabric woven into the world around us. The first major shift is the move to the edge. Think about a self-driving car. It generates an insane amount of data every second from its cameras, LiDAR, and sensors. To make a split-second decision like slamming on the brakes to avoid a pedestrian, it can't afford to send that data all the way to a data center in Virginia, wait for a server to process it, and then wait for the command to be sent back. The round-trip time, the latency, is too long. The decision has to happen now. This is the problem edge computing solves. Instead of a centralized brain, the cloud is developing a distributed nervous system. Small, powerful data centers are being built closer and closer to where the data is actually generated and needed. They're being installed in cell towers, in factory floors, in hospital basements, and inside city traffic light systems. The car can now talk to a tiny cloud server in a 5G tower just down the street. The calculation is made locally, in milliseconds, and the car brakes instantly. The cloud is no longer a distant place. It's moving to the edge of the network, right next to us. This is what will power the truly instantaneous, responsive technologies of the future. Real-time augmented reality, robotic surgery performed from across the country, and entire smart cities that manage traffic, power, and services in real time. The second major shift is happening inside the data centers themselves. It's a move toward complete abstraction, a concept called serverless. For years, to run an application in the cloud, a developer still had to think about servers. They had to decide how many servers they needed, what kind of operating system to run, and how to manage them. With serverless computing, all of that disappears. The developer just writes their code, a single function like process this payment or resize this image, and uploads it to the cloud. They don't provision a server, they don't manage a server, they don't even think about a server. When a user clicks buy now, the cloud provider, like AWS, instantly finds some idle computing capacity somewhere in its massive data center, runs that single piece of code, and then shuts it down. The whole process might take a tenth of a second. The developer is only billed for that fraction of a second of compute time. It's the ultimate pay-as-you-go model. You're not renting a car for the whole month just to make a few trips to the grocery store. You're paying only for the exact moments the wheels are turning. This revolutionizes how software is built. It makes it dramatically cheaper, faster, and easier for anyone with an idea to build and scale a global application. without needing a team of engineers to manage the underlying infrastructure. But the most profound evolution, the one that will define this century, is the cloud's role as the engine of artificial intelligence. Training a large language model like the one that powers ChatGPT, or an image model like Midjourney, is one of the most computationally expensive tasks humanity has ever undertaken. It requires a scale of processing power that is simply unimaginable outside of the cloud. You need to connect tens of thousands of specialized computer chips, called GPUs, and have them all work together for weeks or months on end, processing trillions of data points. No company, no university, no government could afford to build this kind of infrastructure for a single project. But the cloud makes it possible. It allows AI researchers to essentially rent a supercomputer for as long as they need it, run their experiment, and then give it back. The cloud has become the world's AI factory. It's the foundry where these new forms of intelligence are being forged. The photos we store, the videos we watch, the data we generate, all of this has become the raw material fed into these massive cloud-based AI models, which are in turn learning, evolving, and developing capabilities that are beginning to reshape every industry on Earth. So the cloud is no longer just a hard drive in the sky or a rented server. It is transforming into a global, intelligent, and increasingly invisible utility. It is becoming a distributed planetary-scale computer that is moving to the edge, abstracting away its own complexity, and providing the raw power for the artificial intelligence revolution. It's an infrastructure that is becoming as essential as the electrical grid or the water supply. And this raises a new set of critical questions. When a single technology becomes this powerful, this integrated into the fabric of our society, who controls it? What does it mean for our privacy, our jobs, and our future when the most powerful tool ever built is owned and operated by just a handful of companies? The cloud gave us unimaginable power and convenience, but what did we give up in return? We gave up control. We traded direct ownership for access, simplicity for sovereignty. Think about it. When you store your photos, your documents, your entire digital life on a cloud service, you don't own the hard drive they sit on. You don't control the building they're in or the network that connects them. You are, in essence, a tenant. You're renting a digital apartment in a massive skyscraper owned by a corporate landlord. And like any tenant, you have to abide by the landlord's rules. If they change the terms of service, raise the rent, or decide to sell the building, you have very little say in the matter. This has led to an unprecedented concentration of power. The digital world, once imagined as a decentralized frontier, is now dominated by a new kind of empire. Amazon, Microsoft, and Google, their cloud divisions, AWS, Azure, and Google Cloud, are not just companies. They are the foundational infrastructure of modern society. They run the back end for millions of businesses, from tiny startups to government agencies. They host the streaming services we watch, the apps we use, the games we play, and the websites we browse. Even their biggest competitors are often their biggest customers. Netflix, one of Amazon Prime Video's fiercest rivals, runs almost its entire operation on Amazon Web Services. This isn't just a market. It's a digital ecosystem where a few apex predators control the entire food chain. The consequences of this are profound. It creates what's known as vendor lock-in. Once a company builds its entire operation on one cloud platform, moving to another is monumentally difficult and expensive. It's like trying to move that entire skyscraper brick by brick to a new city. This gives the cloud providers immense leverage. And what about our privacy? In this new world, our data is the currency. We pay for free services like email and social media with the most intimate details of our lives. Every search, every click, every photo, every message is collected, analyzed, and monetized. This data is the fuel for the trillion-dollar targeted advertising industry, but it's also the raw material used to train the next generation of artificial intelligence, creating algorithms that will shape our lives in ways we are only beginning to understand. We've entered into a grand bargain, trading privacy for convenience, often without even reading the fine print. But the story of the cloud is not over. It is constantly evolving, and the next chapter is already being written. The very centralization that made the cloud so powerful is now facing a new wave of innovation that seeks to challenge it. We're seeing the rise of the multi-cloud and hybrid cloud strategies. Companies, wary of being locked in with a single provider, are now spreading their operations across multiple clouds, picking and choosing the best services from each. They're also using a hybrid approach, keeping their most sensitive data on their own private servers while using the public cloud for its massive scale and flexibility. It's a way of reclaiming some control, of diversifying their digital portfolio to avoid putting all their eggs in one monolithic basket. And then there's a more radical shift on the horizon: edge computing. If the cloud was about bringing all the data to a central brain for processing, the edge is about bringing the brain out to the data. Instead of sending a constant stream of information from a self-driving car to a distant data center, why not process the critical information like stop before you hit that pedestrian? Right there in the car itself? That's the edge. It's about putting small, powerful computers closer to where data is created and needed. In our phones, in our smartwatches, in factory sensors, in traffic lights. This approach is faster as it cuts down on the travel time for data. It's more resilient because a local device can still function even if its connection to the main cloud is lost. And it can be more private because sensitive data can be processed locally without ever being sent to a corporate server. The cloud won't disappear, but it will become part of a larger, more distributed nervous system, with the central cloud as the cerebrum and the edge devices as the reflexes. Beyond that, some envision an even more revolutionary future: a truly decentralized web, sometimes called Web 3. This is the idea of a cloud with no owner. No Amazon, no Google, no Microsoft. Instead, it would be a network of computers owned by users all over the world, all contributing a small piece of their storage and processing power, coordinated through technologies like blockchain. In this version of the future, you would truly own your data. Your digital identity wouldn't be tied to a corporate account, but to a personal cryptographic key that you alone control. It's a bold and complex vision, and it faces enormous technical and social hurdles. But it speaks to that original powerful dream of the internet as a great equalizer, a platform for the many, not just a property of the few. And woven through all of these futures is the undeniable force of artificial intelligence. The AI revolution we are living through right now is only possible because of the cloud. Training a large language model like the ones powering ChatGPT requires a staggering amount of computational power, more than any single organization could have afforded before the cloud era. These massive planet-spanning data centers are the forges where modern AI is created. As AI becomes more integrated into every aspect of our lives, from medicine to entertainment to science, the cloud will be the engine that drives it. The future of AI and the future of the cloud are inextricably linked. The cloud provides the power and AI provides the intelligence. Together, they represent one of the most significant technological leaps in human history. So what is the cloud? After all this, we can see it's not just one thing. It's not just a hard drive in the sky. It's a business model, a cultural shift, and a new layer of infrastructure as fundamental as the electrical grid or the highway system. It's the invisible architecture of our modern world. It has connected us in ways that were once science fiction, given us access to tools of unimaginable power, and accelerated the pace of innovation beyond our wildest dreams. But it has also created new centers of power, raised critical questions about privacy and control, and presented us with a bargain whose full terms we are still discovering. Understanding the cloud is no longer optional. It's not just for engineers or tech executives. It's for all of us. Because the choices we make now, as individuals, as consumers, and as citizens, will determine what this powerful technology becomes. Will it be a tool for empowerment and connection, or a mechanism for control and surveillance? Will it be a shared resource for all of humanity, or the private property of a select few? The cloud isn't a passive force of nature. It is something we are actively building, every day with every click and every line of code. It isn't just in the sky. It's on the ground, in our homes, in our pockets, and deep in the heart of our future. The question is no longer what it is, but what we, together, decide it will be.